This video is showing examples of converting to vertex form by completing the square. In an earlier video, I explained how to use completing the square to convert to vertex form. So that's what we're going to do 4 examples of how to convert them into vertex form using different types of problems. Number 1, x squared minus 12x plus 7 is equal to 0. As you can see, our a value is equal to 1 and our b value is even, so that means that our completing the square will be relatively simple. As long as your a value is 1 and your b value is even, it's nice and easy to complete the square. Our first step to complete the square is always to change f of x into equal to 0. And as you can see, it already is equal to 0, so we can actually skip that first step. The next step is to isolate the constant, the number without the variable, to the other side of the equals. In this case, I'm going to subtract that 7 to the other side of the problem so that I can isolate it. So I'll end up with x squared minus 12x is equal to a negative 7. Again, as long as a is equal to 1, I do not have to divide everything, and that means I will not have to multiply back into the problem later. The next step is in the workbox, we're going to calculate half of b and square it. So I'm going to take my workbox, I'm going to take a rectangular box where I can calculate half of b and square it. So I'm going to start with parentheses, and I'm going to have divided by 2 inside of it, squared is equal to, I'm going to have my parentheses squared, it's going to be equal to a value. Now the reason why I go ahead and write this out like this is so that I can do them in parts. I don't have to do it all at one time. This is the value I want to get, and remember this number must be positive. Anytime you square a real rational number, it'll become a positive. So I'm going to take our b value, which was negative 12, and put it in our first parentheses because we're taking half of it. Now negative 12 divided by 2 is a negative 6. I'm going to go ahead and put this into that next set of parentheses, because all I've done is just simplified the first set of parentheses to put into the second. I still have not squared it yet, so all I did was take the first set to put into the second set. Now when I take negative 6 and I square it, again this number has to be positive because it's negative 6 times negative 6 is equal to a positive 36. For the next step, we want to make sure we take this value and add it to both sides of the equation. So I want to take it and add it to the left side of the equation and also to the right side of the equation. So when I rewrite this, I keep my x squared, keep my negative 12x, but now I have to add the 36 to this side. The reason we have added this and we have done this is to create a perfect square trinomial so that this will factor nice and cleanly. Equals. Now again, I also have to add that 36 to the right-hand side because anything I do to the left, I have to do to the right. So I really have negative 7 plus 36. Negative 7 plus 36 is actually a positive 29. Now that I've added that 36 to both sides of the equation, I can now factor this trinomial. And again, this trinomial should factor nice and easily. It'll become parentheses squared, because this is a perfect square trinomial, so it will give you something squared. The square root of x squared is x. The square root of 36 is 6. And we have a negative sign here. That means we're going to have a negative sign inside of our parentheses. Now, in an earlier video, I explained that you can always check to make sure this is correct, because whatever you have in this half of b, whatever your half of b was, should be the exact same number inside your parentheses with your x. And it is, so that means that we have done that correctly. This is still equal to 29. The next step to put it into vertex form is to move that constant back to the other side. So in order to move this 29 to the other side, I have to subtract the 29 from both sides. And this 29 is not inside the parentheses, so I don't do anything with the 6. So I'll have parentheses x minus 6 parentheses squared minus 29 is equal to 0. The last step to actually convert it to vertex form is to rewrite it as a function. Now, since in the beginning of the problem I did not know what it was equal to other than 0, this could be f of x or g of x or a y. So we can actually create anything we want. So I'm just going to write this as f of x. F of x equals. I'm just going to rewrite all of the part for the vertex form back into this. So it's going to be parentheses x minus 6 parentheses squared minus 29. I drop off the equal 0 because I already have an equation. I already have the equal sign to make it an equation. So it will no longer be equal to 0. This is now in vertex form, and you can find your vertex by taking the opposite of your, inside your parentheses, your h value, because this is really supposed to be x minus a positive 6 to make that a negative in the middle. So this, your vertex is actually at a 6 and negative 29. So your x value is at a positive 6, your h value is a positive 6, and your k value is at negative 29. On this next problem, go ahead and come over here to number 2. You can see that it is equal to a y, so we do need to change that. The first step is to change it to an equals to a 0. So I'm going to take this problem and put x squared plus 4x minus 7 is equal to 0. Our a value is equal to 1, and our b value is even, so that will be easier to work with. So I need to go ahead and move my constant or isolate my constant to the other side. So I'm going to add this 7 to both sides. So we'll have x squared plus 4x is equal to a positive 7. Again, we're doing this so that we can create a brand new c value to create a perfect square trinomial. To do this, we go to our workbox, which is that rectangular box. We're going to take half of b and square it. So our b value is 4, and the reason why we want b to be even is so that you can take half of it. So half of 4 is 2, so I'm going to put 2 inside the other parentheses. Again, I'm just simplifying this first set to go to the second. So now we have 2 squared is equal to 4. The 4, again, has to be positive, and it is, and we have to make sure we add it to both sides of the equation. So on the left-hand side, we'll have x squared plus 4x plus a 4, because we're just adding that to the left-hand side, equals. Now I have to remember that whatever I do to the left, I do to the right. So I have to take the 7 and also add the 4. So 7 plus 4 is equal to an 11. So I have equals to an 11 over here. Now this has created a perfect square trinomial, so it should factor perfectly. Should factor to parentheses squared. We'll take the square root of x squared, gives us x. The square root of 4 gives us 2. And since we have a positive sign in the middle, we'll have a positive sign in the middle of a parentheses. And again, you can always check back at your half of b. We have a positive 2 right here. That means that inside of our vertex form, we're going to have a positive 2 in the parentheses as well. Is equal to 11. Now we must move that 11 back to the other side by subtracting it from both sides. We'll have parentheses x plus 2 parentheses squared minus 11 is equal to 0. The last step in this is to convert it back into a function. And since our original problem started with a y equals, that's what we're going to end up with for our final answer. We'll have y equals parentheses x plus 2 parentheses squared minus 11. This will tell us our vertex is at negative 2, negative 11. Because, again, vertex form is x minus h. So this is really x minus a negative 2. That's how we get that plus sign in the middle. And then we have minus k, or sorry, positive k. So that means that whatever this sign is, we keep it as this. So this is negative 11. This third example looks slightly different. We have x squared plus 12 equals 10x. The problem with this one is that our variables are on two different sides, and our constant is not isolated yet. So what we want to do is make sure all of our variables are on the same side and our constant is isolated. So in order to do this, we need to make sure our 10x is moved back over to the left but our 12 is moved over to the right. The reason we don't just want to move the x squared is because we want to keep our x squared to be a positive 1. Anytime it becomes something different, we have to do even more work. So in order to do this, we're just going to move the 12 to one side. We're going to move the 10x to one side. So first up, I'm just going to move that 10x by, it's a positive right now, I'm going to subtract the 10x from both sides. And now I'm going to have it in the middle of the problem because it's supposed to be ax squared plus bx plus c. So we have x squared minus 10x plus 12 is equal to 0. Now that we have it back in the standard form, we can move our constant. We can isolate our constant by subtracting the 12 from both sides. So we'll have x squared minus 10x is equal to a negative 12. We had to make sure that we put it back in a standard form so that we could isolate the constant and know which part to isolate. Now that we have isolated the constant, we can go into our workbox so we can create a perfect square trinomial. Again, we're missing our c values for a perfect square trinomial. So in our workbox, we take half of b and square it. So our b value in this case is negative 10. So we have negative 10 divided by 2. Negative 10 divided by 2 is a negative 5. Negative 5 squared is going to be a positive 25. And as always, this number right here must be positive because anytime you square a real value, it'll become a positive. So this value is going to be added to both sides of the equation. We'll end up with x squared minus 10x plus 25 is equal to. We just added the 25 to the left. Now we add the 25 to the right. So we have negative 12 plus 25. Negative 12 plus 25 is a positive 13. From here, we've created a perfect square trinomial. So we factor this. It'll be a parentheses squared. The square root of x squared is x. The square root of 25 is 5. And we have a negative in the middle of our problem. So we have a negative inside of the middle of our parentheses. And again, if we go back to our half of b, this half of b was negative 5, and we have a negative 5 in our parentheses. Equals, still equal to 13. Now to put it back in vertex form, we need to move that constant back to the other side by adding or subtracting. We're going to subtract 13 from both sides. So we'll have parentheses x minus 5 parentheses squared minus 13 is equal to 0. From the original problem, we did not have a y equals or an f of x equals. So again, we can put this as any kind of function we want. We can have it as a y equals, f of x equals, g of x equals. I'll actually do g of x. So g of x equals parentheses x minus 5 parentheses squared minus 13. And again, the equal 0 is gone. And this is our final answer. This is now in vertex form. Our vertex is at 5, negative 13. This last problem is f of x equals, so yes, we do have to convert it into an equal 0. We have an a is 1, but our b value is not even. That does not mean that we cannot do completing the square. It just means that it's going to be a little more tricky. So as always, we convert this to equal to 0. So x squared minus 5x plus 10 equals 0. We're going to isolate our constant by subtracting this 10 away from this. So subtract 10. We'll have x squared minus 5x is equal to a negative 10. Now the reason why this becomes a little tricky is because we can't take half of b easily. It won't give you a nice whole number. It'll give us a fraction, but we're going to keep it with fractions. Fractions are much easier to work with than decimals when you are having to add and subtract without a calculator. So as always, we're going to take our workbox we're going to take half of b and square it. So I'm going to set that up. I'll always set it up the same way. So our b value is a negative 5. So negative 5 divided by 2 just remains as negative 5 over 2. So I'm going to rewrite that exact same thing inside our second set of parentheses. Because all I've done is just simplified this, and I've got negative 5 over 2. Now I'm going to square it. So negative 5 over 2 squared, I'm going to square both the top and the bottom of our fraction. So we end up having a positive 25 over a positive 4. We're going to add that value, since it's a positive 25 over a positive 4, to both sides of our equation. So we will have x squared minus 5x plus 25 over 4. And again, we want to keep it as fractions because they're much easier to manipulate, is equal to. Now I have to take that negative 10 and add 25 over 4. Now in order to do this without a calculator, we need to have a common denominator. To have a common denominator, this denominator right now on the negative 10 is a 1. So the least common denominator will be a 4 because I need to make the 1 go up to a 4. Now to convert this, I need to multiply both parts of this by 4. So I really have a negative 40 over 4. And if I were to simplify that back, 40 divided by 4 is 10. So I still have a negative 10 here. I've just converted it. I've just changed it so that I can add the 25 over 4. Now when I add these, I'm going to keep the denominator as a 4. And so I'll have really a negative 40 plus 25, which is a negative 15. And I keep the divided by 4. We still have a perfect square trinomial over here because we have a perfect square here and a perfect square here. And if I were to take the square root of these, I'd get that negative 5 over 2. Or I'd get a 5 over 2, and the negative sign comes from the middle. So I'm going to go ahead and factor this. I do have parentheses squared. The square root of x squared is x. I'm going to take the square root of 25 over 4. When you take the square root of a fraction, you take the square root of the top and the bottom. Square root of 25 is 5 over the square root of 4 is 2. And then if we look in the middle, we have a negative sign in the middle, so the negative will go in the middle of the parentheses. So we come back up to the half of b. I have a negative 5 over 2 in the half of b, and I do here in the parentheses as well. So I know that that is correct. Is equal to a negative 15 over 4. So we're going to move that negative 15 over 4 back to the other side. We're going to add the 15 over 4 to both sides. We have it as parentheses x minus 5 over 2 parentheses squared plus 15 over 4 is equal to 0. And the last step is just convert it back into a function. We originally started with f of x. So our final answer will be f of x equals parentheses x minus 5 over 2 parentheses squared plus 15 over 4. So our vertex is at a positive 5 over 2, positive 5 over 2, which is 2.5, and a positive 15 over 4, which is a 3.5. So then we could actually graph that in decimal format and plot coordinates. So this is our vertex form. And the reason why this one was a little trickier is because you could not actually take half of the b and give you a whole number, an integer. We kept it as a fraction. But you can square fractions much easier than you can decimals, and you can add them much easier than decimals as well. This was completing the square, converting standard form to vertex form by completing the square.